Hello, today we are going to discuss about the next data structure, that is queue. Okay. So, queue is again a linear data structure, and in this data structure we generally perform many operations or many applications are there in our computer science. So, let us have a look about the queue data structure and how it is implemented, how we are going to implement this in programming, that we are going to look. So, queue, it is an ordered list of elements, some elements are always ordered, and the insertion at one end, say for example, I have some memory space, this is some memory space, say for example, I have some array, okay, 0, 1, 2, 3, 4, 5, 6, 7, I have an array of size 8. So, this array of size 8, I want to insert some elements, and these elements when will be inserted from one end and that will be deleted from another end. So, the insertion is from one end, that end is called rear end. So, we are calling this end as rear, or we can call it as tail. Now, the another end, the deletion of elements are from another end, and that end is called front end. So, whenever we have, say for example, we have inserted some element, so that is 20 will be inserted here, then I want to insert another element like 30, that will be inserted here, and then 40, that will be inserted here, 50, and these elements will be inserted in this way. Now, whenever we are trying to delete some element, so the element will be deleted first, 20, the first element which is inserted, and that element will be deleted first. Then if we want to delete some another element, then 30 will be deleted, then 40 will be deleted, then 50 will be deleted. So, this way, so queue performs its job, and that is why it is called first in first out. The element which is inserted first, that element will be deleted first, and the same way the last in first or last out, that means the element which is inserted last, say let us say for example, here the element which is inserted at last, that will be deleted at last. Now, let us have a look about the applications of queue. So, there are different applications, say for example, there is one scenario, think about a scenario, this is a printer, okay. This is a printer, and this printer is shared by multiple peoples. So, this is computer 1, this is computer 2, this is computer 3 and computer 4. So, there are different computers or different persons who are sharing this printer. Now, this resource is a shareable resource, this resource is shareable resource, okay. This person are sharing this resource. Now, when they are trying to print some job, they are trying to print something, then these jobs will be stored. There is a particular storage place, and this storage place, if you think about, this is an array, and they will be the elements, the task which will be need to be printed, that will be printed as per their arrival. Say for example, C1 is trying to print a document named as A. So, A is inserted first, then C2 is going for another document to print. So, if we are assuming that B arrived next, then say for example, C4 is trying to print another document, that is K. So, that will be here. So, this way the arrive as per their arrival of the different tasks, they will be stored in the memory. So, in the printer also, A document first it will be printed, then B document will be printed, and then K document will be printed. Let us have another example like the operating system scheduling jobs. Say for example, in our operating system, so this is our, say for example, this is our processing unit or the processor. Now, whenever we are trying to perform multiple jobs, multiple tasks or multiple process, then those things are say for example, there is one particular memory space is again used there, and this particular memory space is also called ready queue. So, this ready queue having some space. So, if the process number P1 arrive first, then say for example Px, if I say P, this is Py arrived, then Pk arrived, then Pj arrived. So, as per their arrival, they will be inserted in this particular queue. And whenever they are going to process by help of the processor, they are going to go for some task. So, first Py will be processed or get entered, or it will be entered in the processing scheduling. Actually, there are different states are available, like waiting state, running state, block state. There are so many states are there. So, P1 will enter in this particular place where we are going to execute, CPU is going to execute all the process, then Px will be entered, then Pk will be entered, then Pj will be entered. So, if you observe in this particular data structure, the elements which are going to store, we are going to store, they are stored in a particular manner. That means, all the elements are stored one by one, and the element which is entered first, that will be deleted first. So, that is why this data structure is called first in, first out. So, another example, say for example, like ticket counter, we all observed whenever in railway station, in railway, whenever we are in window booking, whenever we are trying to get some ticket, in that case also we are performing the same operation. We generally go for the person who entered, who entered in the queue first, then that person will be will get the ticket first. So, another example, like asynchronous data transfer in our system also, whenever we are trying to transfer some data, in that case also, in asynchronous data transfer case, the data will be transferred in this particular data structure. Another example is like ready queue. Let us have an example of this particular ready queue. So, say for example, we have a router. Okay, this is a one router. Okay, or router. Okay, so there are another routers or routers are available. Say for example, these are the routers or routers. Now, I am trying to transfer some packet, transmit some packets through this router. Okay, say for example, this I am sending some data through this router, and the definitely the channel bandwidth or channel speed must be different for each cases. Say for example, this the speed in which the data is coming here, it may be quite possible, may not, or quite possible this channel is not able to transmit all those data in the same speed. So, what will happen? So, definitely you will say, okay, if I am getting huge number of packets, say for example, this per second it is transmitting 5 packets per second. Sake of example, I am assuming 5 packets per second this particular router is sending. This particular channel is sending 5 packets per second. This packet or this is also sending, say for example 15, this is also sending 7 packet per second, and this channel can able to send only 20 packets per second. So, what will happen? So, definitely how many packets are there? That is 20 and 7, that is 17 packets are for every second we are getting only 27 packets. For every second, this particular router is having 27 packets. Now, it can able to send only 20 packets. So, 7 packet, what we will do with the 7 packet? So, that is the issue. So, what we will do? What is happening in this router? There is a particular queue is used. This queue is called routing queue. What will happen in this queue? The extra packets will be stored. The extra packets will be, say for example, say for example, PA, PM, PX, PY, they will be stored in this particular router. And as per the time will come when it will be, the load will be less, or whatever the scenario is as per the depending on the situation. So, what will be happen? The packet which is arrived, that packet will be delivered. So, PA will be delivered first, then PM will be delivered, then PX will be delivered. So, this way all these packets will be stored in a particular queue and they will be delivered as per their arrival. So, that means the packet which is arrived first, they will be delivered first. So, the same thing in our printer also, whenever we are trying to print some job. So, different peoples are just they are sending their printing job to the printer. So, how the printing jobs arrived in the printer, and the same way they will be delivered or printed. In the same way, in our system also, as per the process, when we perform some kind of task. So, all the tasks will be stored in a particular queue. This queue is generally called ready queue. In this queue, the values will be, or the process will be stored, and as per the convenience as well of the system CPU will allocate them, or they will be assigned for the next execution. So, these are the different examples of queue, and also indirectly there are so many applications are also available in our computer science or in our domain. There the queue particular data structure is used. Okay, thank you for today.